Hi children, yesterday I explained about the atomic structure. How many members completed? Have you learned? Have you prepared that atomic structure? So what I explained in that? Introduction of the atomic structure. What is the importance of the atomic structure? And introduction. And what is the importance of the chemical reaction? And also properties of elements, and also the behavior of the matter. So these are the three important points I explained about the atomic structure importance. Okay, so how many members prepared? So if you are not prepared, prepare well. Okay na? So that is in that I explained about the Dalton atomic theory, postulates, and also drawbacks of Dalton's atomic theory. So everyone should prepare Dalton atomic theory. So today I am going to explain the difference between the Dalton atomic theory and modern atomic theory. So let us discuss about the differences between the Dalton atomic theory and modern atomic theory. So this is the modern atomic theory. This is the Dalton atomic theory. So already I explained about this Dalton atomic theory. Now I am going to explain this modern atomic theory. I am comparing with the Dalton atomic theory. So what is present? Matter consists of small indivisible particles. These are called atoms. But this is only the atom is the ultimate particle of the matter. But in the case of modern atomic theory, so atom is no longer indivisible. So it contains electrons and protons and neutrons. It contains electrons, protons and neutrons. After the atom, electrons, protons, neutrons also present in that atom. Okay, right? So this is the electrons, protons, neutrons also present. So next one, atoms of same element are alike in all aspects. Suppose he is saying about the atoms. So I explained about here atoms of the same element. So here carbon C612 and carbon C613. So these are the same element, atoms of same element are alike in all aspects. But Dalton's theory, what I explained, atoms of the elements have same mass and same properties. Atoms of the elements have same mass, same properties. రెండిటికి అన్ని అటమ్స్కి కూడా సేమ్ మాస్ ఉండాలి, సేమ్ ప్రాపర్టీస్ ఉండాలి. ఆ ఎలిమెంట్ యొక్క మ్యాటర్కి హైడ్రోజన్ గ్యాస్ తీసుకున్నాం అనుకో, హెచ్ అన్ని ఆటమ్స్ ఆఫ్ సేమ్ ఎలిమెంట్స్, ఆల్ ఆటమ్స్ ఆఫ్ ద సేమ్ ఎలిమెంట్ హ్యావింగ్ సేమ్ మాస్ అండ్ సేమ్ ప్రాపర్టీస్. అండ్ బట్ ఇన్ దిస్ కేస్, ఐసోటోప్స్ కేస్, ద మాస్ ఈస్ డిఫరెంట్. Mass is different. So that's why atoms of the same elements are alike in all aspects. But in this case, all atoms have isotopes. It means atoms of the elements have different atomic weights. See, this is the drawback of the Dalton's theory. But in this case, but he is saying C carbon 12, C carbon 613, C carbon 14. So it is possible here. Isotopes, the atomic mass is possible here in the modern atomic theory. But in the Dalton atomic theory, this is not possible. Is the drawback. So that is modified by modern atomic theory. Understanding? So let's go to the next question. Atoms of the different elements are different all aspects. Atoms of the elements have different elements, different mass, different properties. But in the case of isobar is the drawback. But in this case, different elements, different properties. But isobar case, so isobar is what? Carbon C614, here I am taking C614 also, C614 and nitrogen 714. This is the isobar. Isobar is 14. Mass number is same, but in this case atoms of the different elements have different in all aspects. That is the Dalton atomic theory. But drawback of Dalton atomic theory, this is drawback. Atoms of the different elements have same mass. But that was modified by the modern atomic theory. So in modern atomic theory case, atoms of the different elements are sometimes similar. Sometimes similar in all respects. For example, atoms of the argon calcium case. Argon 1840. Argon 1840 and calcium 2040. In this case, mass number is same. Mass number is this 40. Argon 1840, potassium 2040. The mass is same. That was modified by the modern atomic theory. Modern atomic theory lo isobars case, isotopes case modify అయింది. కానీ ఈ కేసులో isotopes కేసులో atoms of the elements are alike in all aspects. alike చూడండి 12, 13, 14. మాస్ అనేది డిఫరెంట్గా ఉంది. ఓకే, ఇక్కడ డిఫరెంట్ ఎలిమెంట్స్కి మాస్ సేమ్ ఉంది, కానీ ఇక్కడ డిఫరెంట్గా ఉండాలంటున్నాడు. ఈ ఐసోబార్ని ఇక్కడ మోడిఫైడ్ చేస్తాడు. ఎగ్జాంపుల్ అది, ఈ ఎగ్జాంపుల్ అయినా తీసుకోవచ్చు, ఈ ఎగ్జాంపుల్ అయినా తీసుకోవచ్చు. ఆర్గాన్ 1840, కాల్షియం 2040. ఈ ఎగ్జాంపుల్ అయినా తీసుకోవచ్చు, ఈ ఎగ్జాంపుల్ అయినా తీసుకోవచ్చు. యూ మే టేక్ దిస్ ఎగ్జాంపుల్ ఆర్ యూ మే టేక్ దిస్ ఎగ్జాంపుల్. బోత్ ఆర్ అండర్కమ్స్ ఇన్ ద మోడర్న్ అటామిక్ థియరీ. బట్ దిస్ theory tells about the atoms of the different elements are different in all respects. Understanding? But in this case, different elements are sometimes similar in the some respects. That means carbon, nitrogen 14. But in this case, argon 1840, calcium 2040. Next case, atoms have combined in small whole numbers to form compound and forms atoms. But in this case, atoms in organic compounds don't combine in the small whole number ratio. The molecules, proteins are highly complex. ఇక్కడ molecules రూపంలో combined అయి ఉండవు. ఏది? Atoms in organic compounds don't combine in the whole ratio. Atoms అనేవి ఆర్గానిక్ కాంపౌండ్స్లో కంబైన్డ్ అయ్యి ఉండవు హోల్ నెంబర్ రూపంలో. కానీ ద మాలిక్యూల్స్ ఆర్ ప్రోటీన్స్ ఆర్ హైలీ కాంప్లెక్స్. కాంప్లెక్స్ అంటే పెద్ద మాలిక్యూల్స్. ప్రోటీన్ అనేది పెద్ద కాంప్లెక్స్. అది ఆ మాలిక్యూల్స్తో కంబైన్ అయి ఉంటుంది. సో ఆటమ్స్ అనేవి ఉండవు దాంట్లో. కానీ ఈ కేసులో ఆటమ్స్ అన్ని కంబైన్ అయ్యి మాలిక్యూల్ రూపంలో ఉంటుంది. ఇక్కడ వచ్చేసి మాలిక్యూల్స్ అన్ని కంబైన్ అయిపోయి ఒక కాంప్లెక్స్ పెద్ద మాలిక్యూల్గా ఫామ్ అవుతుంది. ఆటమ్స్ అనేది ఉండదు అక్కడ. రైట్. ఆటమ్స్ ఈజ్ ద స్మాలెస్ట్ పార్టికల్ which takes place in a chemical reaction. Here atoms which are involved in the chemical reaction. Atoms of matter. Atom is the smallest unit of a matter which takes place in a chemical reaction. So this is about the differences between the Dalton's theory, modern's theory, contradictions, Dalton's theory and by modern atomic theory. So this is about the contradictions. See here what is given: characteristics of the three fundamental particles. So atom contains three main fundamental particles. Those are subatomic particles: electrons, protons, neutrons. So see here symbol is given, next relative mass given, charge given, and here mass in kgs, mass in units, and actual charge. See here, let us discuss about this part. First one symbol, relative mass, relative charge and mass, kgs, mass in AMU. Let us see, this is particle. Let us take the particle and electron, proton, neutron. So first one, let us see about the first particle. Here particle property I am writing the particle property. So first property, let us see the representation, that is symbol. First one is the symbol. Symbol of electron. Electron symbol is just E minus. The proton symbol is P plus or P also you can write. Neutron symbol N. Electron charge is negative, proton charge positive. This is neutral, no charge. So next one, charge. Charge of electron. Charge of electron 1.602 into 10 power minus 19 coulombs. This is coulombs, but this is showing negative. We should write negative. And here plus 1.602 into 10 power minus 19 coulombs. This is, there is no charge, 0. And in a ESU, electrostatic units, minus 4.8 into 10 power minus 10 ESU, electrostatic unit. Here plus 4.8 into 10 power minus 19, 10 power minus 10 ESU. Here that is 0 only. So what I am telling here, this is the charge, electron, proton, neutron, and this is represent symbol, electron showing negative, showing positive, showing N. This is about the charge, either coulombs or ESU. ఏంటమ్మా ఇది? కూలుమ్స్లో అవ్వచ్చు లేదా ESU, ఎలక్ట్రోస్టాటిక్ యూనిట్. నెక్స్ట్ది థర్డ్, mass of electron. Mass of electron. Mass is 9.1 into 10 to the power of minus 31 kgs. This is in kgs. Mass of electron is 9.1 into 10 power minus 31 kgs. This is 1.672, sometimes 1.673. In some textbooks 1.672 is there, in some textbooks 1.675 is there. 1.672 or 1.673, okay, into 10 power minus 27 kgs mass. This is 1.675 into 10 power minus 27 kgs. So this is about the mass. Mass of electron, mass of proton, mass of neutron. Here difference is 1.672 into 10 power minus 27. Here 1.675 into 10 power minus 27. Here the difference is this, in this case only. This is only the difference. The remaining is same only. 1.675, this is 1.672. So which is more mass here? Then mass of neutron is slightly more than the mass of proton. The mass of proton is slightly less than the mass of neutron, or the mass of neutron is more than the mass of proton. Understanding what I am telling? So they will ask, mass of neutron is more than, slightly more than mass of proton. This is about this. 9.1 into 10 power minus 31 kgs. This is very less, small. The mass of electron is very less, minus 31 kgs. This is in kgs. I want in grams. 9.1 into 10 to the power of minus 28 grams. Why? 1 kg is equal to how much? 10 cube, 1000 grams. 1000 grams means 10 cube. So here instead of 1 kg you write 10 cube. 10 power minus 31 into 10 power 3. Then what is the value? 10 power minus 28. This value, see 1.672 into 10 to the power of, here also 1 kg means 1000 grams, 10 cube. Then base are equal, power should be added. Minus 27 plus 3. How much? Minus 27 plus 3. How much, ma? So 10 power minus 24. Bigger value is having minus. So this is in grams. Here 1.675 into 10 power minus 24 grams. I am taking again in AMU. AMU I am taking now. AMU. This is kilograms or grams. This is kilograms or grams. This is kilograms or grams. Okay na? Next, OR in AMU, atomic mass unit. This is 0.000545 AMU, atomic mass unit. 0.000545. This is, can I write like this? This is 5.45 into 10 power minus 4 AMU, atomic mass unit. 0.00, how many zeros here? 3 zeros. After decimal, 3 zeros, 545 AMU, atomic mass unit. Instead of that, I have written 5.45 into 10 power minus 4 AMU. Because the decimal turns towards the right side, how many numbers? After 4 numbers. Then I am keeping 10 power minus 4. This value increasing, this value decreasing, power value decreasing, this value increasing. 0.0000545 na 5.45 I have written. So this is there in book. Okay, next here 1.67 into 10 power minus 24. This is in grams, but in AMU 1.00787 AMU. This is 1.00878 AMU. But you remember up to here 1.008, here 1.007. You remember up to here. This is about the electron and proton, neutrons. These are the fundamental particles. Fundamental particles of a atom. These are called as subatomic particles. These are called as subatomic particles. These are called as fundamental particles. Fundamental particles. Fundamental particles. How many fundamental particles? 3 fundamental particles. These are also called as subatomic particles. These are also called as subatomic particles. Subatomic particles. So this is about the electron, proton, neutron. Who discovered electron? J.J. Thomson. Who discovered proton? Goldstein. Who discovered neutron? James Chadwick. Electron ever discover చేశారు? J.J. Thomson. Proton ever discover చేశారు? Goldstein. Neutron ever discover చేశారు? James Chadwick. Discover చేసింది scientists different. The name of the electron was given by another scientist. పార్టికల్స్ ఎలక్ట్రాన్, ప్రోటాన్, న్యూట్రాన్ కనుగొన్నది ఒక సైంటిస్ట్ అయితే దానికి పేరు పెట్టింది ఇంకొక సైంటిస్ట్. అదొకసారి చూద్దాం. ఎలక్ట్రాన్, ప్రోటాన్, న్యూట్రాన్ ఫస్ట్ డిస్కవర్ చేసింది జే.జే. థామ్సన్. జే.జే. థామ్సన్. నెక్స్ట్ ప్రోటాన్, Goldstein. Proton was discovered by Goldstein. And neutron was discovered by James Chadwick. James Chadwick, Chadwick, James Chadwick. And next this is discovered scientist. Discovered. Next scientist, name of the electron protons was given by, name, about name is given by, this is G.J. Stoney, and this is Rutherford, and this is same James Chadwick. So this is about the discovery, and a name was given by different scientists given for different particles. One is electron was discovered by J.J. Thomson, proton was discovered by Goldstein, neutron was discovered by James Chadwick. Next, the name of the electron was given by G.J. Stoney, the name of the proton was given by Rutherford, and the name of the neutron was given by Rutherford. Let us see what is present in the book. This is I explained. Yes or no? Everything I explained. This table. Relative charge, but this point only I didn't explain. I have not explained this one. So relative charge of the mass. This is the mass of electron. How much it is? 1 by 1836. 1 by 1836 times of the mass of the proton. This is the relative mass of the electron. How many times? 1 by 1836 times. Then you will get this value. Then the proton is 1, the neutron is 1, because 1, here 1 is there. Yes, here 1 is there now. That is this. If you divide 1 by 1836, definitely you will get this value. This is already given 1.007, that is almost equal to 1. This is 1, this is 1.008 given. This is about the fundamental particles, electron, proton, neutron. Explained symbols. Relative mass, that means relative mass means mass. Relative charge, that is in kilograms, grams, AMU. And also next, charge, the charge of electron, proton, neutron. So that is in coulombs and electrostatic unit. Electrostatic unit and coulombs. Coulomb means, or ESU, electrostatic unit means, these two are unit of charge. So this is about the fundamental particles or subatomic particles. How many? 3. Let's go to the next part.